Problem number one. Oh boy. Oh boy. Problem number one. Find the decimal form of 15/8. How do we do this? What?
Just 15 goes into 8 one time, and then you're just like 4%.
It's a division. You had to set that backwards, but you're exactly right. It's a division. Doesn't this mean 15 divided by 8?
Yeah.
And if I were doing it by hand, it would look like this, right? But I told you, you always have access to a baby calculator. So if anybody got a calculator out, I want to put those out now. If anybody got a calculator, tell me what is 15 divided by 8?
1.875.
1.875. Easy. To convert a fraction to a decimal, it's a division problem. All right, well, what about negative 11/6? Negative 11 divided by 6?
Negative 1.83 repeating.
Negative 1.83 repeating. Everybody know that one law means repeating. Right? Now, these are fractions. Fractions can always be changed into decimals. Sometimes the decimals turn out to be terminating. That means they stop. And sometimes they turn out to be repeating. Like this one. Terminating and repeating decimals make up what we call the rational numbers. The rational numbers. Some decimals don't terminate or repeat. Right? They're weird. Can you think of one? Yeah, right on the board over there. Pi. Does not terminate, does not repeat. Those numbers are called irrational. So non-terminating, non-repeating. Those are irrational. But our focus right now is on rational numbers, fractions. If you're a fraction, you're rational. You're either going to terminate or you're going to repeat. All right, part 2, shifting gears a little bit. Can anybody read that? What does that say? It says x is greater than 3. When I grab that on the number line, open circle at 3 and shade it to the right. Very, very good. Why is the circle open?
It's not greater than or equal to.
Because there's no bar underneath it. That colors it in. That colors it. How about this one? Can you graph this one on the number line? It has 2 numbers. So we'll have a dotted -4 and a dotted 2. Those are the 2 numbers in the problem. And that one.
You fill in the 2.
I fill in the 2. Everybody good with that? Filling in the 2. And what?
And then you fill in the space between the 4 and the 2.
Shade in between. In between. Wait, very confusing problem here, but let's look closely. See that X? Where is he sitting? In between the 2 numbers?
Yeah.
That tells me where to shade. Okay, I'm going to shade in between those 2 numbers. Perfect. Now, what about this? Do you guys remember from last here. Do you remember what that represents? Now, don't be confused. If I was walking down the hall and found that, I would immediately think about that point right there, -1, 3. But that's not what we're talking about. We're talking about a number line now. This actually means an open dot at -1, an open dot at 3, and everything in between. This is what we call an open interval. -1 to 3, all the numbers in between -1 and 3. Now wait, Mrs. Ford, how did you know that was an open dot? Well, look at the next one. What do you notice about that problem? There's a bracket. The bracket means a closed dot. So anytime you see parentheses, that's an open interval, that's an open dot. When you see the closed parentheses, the closed bracket, that means you have a closed dot. Always, you're gonna shade everything in between. Just when we thought maybe we were figuring out what was going on here, look at the next one. Anybody have any idea how to handle that?
E.
You start at 4 and you shade everything like to the left.
We're gonna have 4, and the dot at 4 will be closed. And then what?
And then you'll shade to the left everything.
How does she know to shade the left? Because the other number is -infinity, and isn't -infinity out here? Please don't put a dot for -infinity. -infinity isn't plottable, you just keep going forever and ever, but it's in this direction. So she's exactly right, and then shade everything forever and ever in that direction. Beautiful. As long as I can tell her shaded, yeah. Now, you know what this means, we just talked about it. This means I have a dot at 4 and a dot at 6, and I'm shading between, that's what that means. Now, the directions say, write it as an inequality. So in other words, write it with these symbols. That means you're an inequality when you write it that way. Anybody figure out how to write that guy? As an inequality? Take a long guess. Worst thing can happen is you'll be wrong, okay?
It's greater than 4 but less than 6.
So in other words, X is right in between 4 and 6.
Yeah.
When you write, this is called compound inequality, when you write the compound inequality, these symbols will always be less than. X is bigger than 4, X is to the right of 4, but it's less than 6 to the left of 6. Always use less than. All right, how about this one? Got an idea on that one? Yeah, what
When you fill in your circle at 6, not at
Okay, so graphing, I have a 6 filled in, and then shade it this way toward infinity. That's a picture. Now, can you write it with one of these symbols?
less than x, less than infinity.
put in, that's a great idea, we never put an infinity in. So it would just be 6 less than or equal to x. Now that is perfectly fine. She said less than infinity, we don't put that part on there. Mrs. Ford isn't gonna write it that way, this is fine, no problem. I'm always gonna write it this way, because I have this thing about having my variable first. It looks backwards to me when it's written that way, but it's correct. But I like to write it this way. This says x is greater than 6. I thought, see, this is a picture now. The picture's already on. Who's got an idea here? Yep.
X is, greater than or equal to 2. Wait, which one are you on, C?
We're on C. Are we on 3C?
Oh, my bad, I was looking at 4.
It'll be -1. Greater.
Actually, less than x, less than 5,
One will be less than or
or equal to on the 5, because that's a closed-end dot. Remember, when you write a compound inequality, when you're shaded in between two numbers, these are always less than. All right, now I need an interval for problem A. In other words, I need parentheses and/or brackets for problem A. What do you think? X is between 4 and 9. What's that gonna look like?
It would just be 4, like, let's see, 4, 9.
That's exactly right. Why are those parentheses?
Because there's no or equal to.
Well, yeah, there's no minorities, there's no counts, so 4 and 9. How about B? Anybody have a thought on that? We're using parentheses or brackets.
brackets.
Bracket -3, comma, 6, parentheses, beautiful.
What's the bracket for?
What?
What's the bracket?
Or equal to, closed dot, parentheses are open dot, and C. What's that one gonna look like?
Just X is greater than or equal to 2.
Now, that is exactly right for an inequality.
Oh.
I need that as an interval, okay? So again, he is not wrong, that's it, but that's the wrong form. So what do you think?
One bracket and then a 2 and then an infinity and a bracket.
Now, I think everybody in the room hopefully understands why there's a bracket there on the 2. Why is there parentheses on the infinity?
It's never
There's always a parentheses on the infinity, yes, very good. Correct? You can't find infinity to put a dot on, right? So it has to be open. It has to be open. Beautiful, beautiful, beautiful. All right, switching gears again. This first section is full of all kinds of stuff. Where it says additive inverse, above that, write the word opposite. Additive inverse means opposite. So basically, what you're being asked to do is write the opposite of -3 plus 1. The opposite would be 3 minus 1. The opposite, you change the sign. So +3 and -5. Perfect. What about 16? What is the additive inverse for the opposite of 16? All right. Part 6, doing our distributive problem. This is a problem we're all familiar with. squared plus 6xy. Everybody good with that?
Yeah.
All right, let's skip to D. I'm skipping to D. What do I get when I distribute in D?
10x cubed minus 6xy squared.
Squared y?
Yep.
Everybody okay with that? Now we're skipping to F. What do I get in F?
Negative 6x plus 21y.
Everybody catch that plus right there? That's one of those things we all know, but sometimes we forget it. And distribute that negative. All good? All right, now let's go back to the ones I skipped. Problem B doesn't look the same as these, right? But we can still do the distributive property. We're just going to do it in reverse. The backwards distributive property is called factoring. We're going to factor this. So let's look at that guy. We're going to undistribute it. What can we take out?
X.
And if we do take out an x, what will be left?
5x minus 8y.
Everybody good with that? Beautiful. How about C? Can you do the same thing with C? Let's see, I need to hear from someone I've heard from. Have I heard from you? All right, undistribute that, factor that for me.
Yeah. Plus A plus, I mean, C five.
Did she factor? Oh yeah, she factored. This isn't wrong. This just isn't done. Because you took out an A, which is totally fine, but you've taken out any more. You can also take it out of Z. Is there anything else you could have taken out? How many A's do we have right now? 3? How many do we have right now? We always take out the most that we can. So we're gonna take out 2 A's and that's it. How does that work? Is that it? Is that all I can take out?
Yeah.
So what will that leave me with then? If I take out 2 A's and a Z, all I'm gonna have left here is A. And all I'm gonna have left here is Z to the 4th. Now that's called factoring. But how do you check it? You check it by distributing it. All right, last one. E, take a minute, you and your partner. That's who you're sitting next to or in front of or whatever. And see if you can figure out how to factor that guy. I want to hear from somebody I haven't heard from. Like, pretty well. Have I heard from you yet? All right, you ready to share? What do you think? taken out?
I simplified them both and I took out 16.
Took out 16. So when you took out 16, you were left with 10A minus 2B, is that correct?
Yes, ma'am.
Perfect. Now, you're grading his paper. Is he gonna get partial credit or full credit? He's gonna get almost all the credit. I want you to look at your parentheses here. What about the 10 and the 2? So instead of taking out 16, which wasn't wrong, this is not wrong, it just isn't done. Because instead of taking out 16, I could have taken out 32. And if I take out 32, then that's going to be 5A minus B. Again, not wrong, just not done. You gotta keep an eye on it and make sure that you've taken out everything that you possibly can, just like we did over here. All right, anybody have any question about that? You gotta crank through some more, and we'll catch up with you. All right, number 7. Your job is to simplify this. And I don't want you to make it hard. Please, we're gonna do enough hard stuff. Don't make this hard. Common sense. What's gonna happen with these X's right here? What's gonna happen with those X's?
Subtract them.
They're gonna cancel, aren't they? You can subtract the exponents for sure, but aren't they gonna cancel? If you have 3 X's on top of 2 X's, aren't they gonna cancel? And what are you gonna be left with? 1 X on the top? So we're gonna have an X on the top. Okay? Now, what about the Y's? Aren't they gonna do the same thing? But now the extra is on the bottom, so that simplifies the X over Y. We're not gonna make it hard. If we don't have to. B is a different story. B is here. Anybody know how to handle this guy?
Don't you, times -2, top and bottom?
Okay, we're not, take everything to the negative second power. That exponent actually goes with everything, right? And you can do that. It's easier, I think, to remember that negative exponents move things. So do you remember that if you have a negative exponent in the numerator, it goes to the denominator? And if you have one in the denominator, it goes to the numerator. So negative exponents move things. Now, this negative exponent is on the whole fraction. So what's gonna happen to this fraction? It's gonna flip. And then the exponent is positive. And in your world and my world, positive exponents are best. Negative exponents are confusing. So I flip my fraction. Now, Philip, you're right. Everything is going to get squared. So X is gonna get squared. The Y is gonna get squared. And the 3 is gonna get squared. Don't put a 6 down there. It's not 3 times 2. It's 3 to the second power. Alrighty. What a mess. Any thoughts on having this squared?
Square.
It'd be 16.
16.
Oh, 16, but they're still good.
Boy, that's an easy mistake to make. Pay attention. Remember everything gets squared, including the 4. So we have 16x to the 4th, and then we solve our y to the 5th and 4x squared. Now, one thing at a time. What happens here? 16 over 4. 4. Right? What happens to my x's now? I've got 4 of them over 2 of them.
X squared.
X squared on the top. So I don't have anything at the bottom. Now, I want you and your partner, this looks wacky, wacky, wacky. I want you and your partner to spend a couple minutes on this, and then I want to hear your ideas, okay? We're simplifying this guy. Remember, negative exponents move here. So if you have a negative exponent, you are moving.
On the bottom,
Yeah, it's a 3. Okay, and then you flip, if you flip both because they're negative, this would be a positive 5 over 3.
Wait, are you
Or the bottom would be positive 3.
Are we like just subtracting the exponents here? Is that what we're doing for this different? So when you put the exponent like to the bottom, that makes
All right, I want to hear your ideas. Tell me,
that makes a lot of sense.
what did you do with your x's? What did you do with the x's?
X6 in the denominator.
X6 in the denominator. I love that. Why are there 6 x's in the denominator? Because there were 4 to start with, and we moved 2 more down. Remember, negative exponents move. Perfect. Beautiful. Somebody else, tell me what you did about the y's. I'm not ignoring you, Devin, but you and Philip have answered about every question. Give someone else a chance. Really?
Y squared.
Where?
Like on the top.
On the top, y squared.
Z's was
Now, this one, she's right, 100% correct. But this one's a little bit harder. See how they're both negative? That means they both move. So the 3 comes to the bottom and the 5 goes to the top. Can you see now why she said y squared on top? All right. Bella, you got the z's for us? What'd you say about the z's? And did you put that on the bottom or the top? Top. So let's talk about that. She said I added the exponents, put 7 on the top. That would be absolutely correct if we had both of them on the top to start with. Unfortunately, we have one of them on the bottom. So if I look at this, Dawn, and I'm not saying you have to write this out, but this is z over z, 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 z. That's what it this guy will cancel. And what's left? C to the fifth, 5 C's on the line. Exponents are tricky. We're just reviewing, I know you did it last year, but we're just reviewing now. We're gonna practice some more. Pay attention to where you are, top or bottom. All right, E, I don't even think I need to write this one down. Can anybody tell me what E is?
X5 over 27.
One guess is X to the fifth over 27. Let's talk about that. What does it mean when we cube something? When we say take something to the third power, what does that mean? We multiply it times itself 3 times. So that means x squared times x squared times x squared, doesn't it? And that's xx, xx, xx. How many x's do I have? 6. I multiply those exponents. I am 100% with you. There's too many rules. Gotta keep track of it all. Oh, you just wait. We're gonna get tons more rules for all kinds of problems. If you forget a rule, do I add those? Do I multiply those? Work it out, just like I did. Write it out. You can always figure it out. It's x6. I absolutely love the fact she said 27. People miss this all the time, not her. Where'd she get 27? 3 to the third. 3 to the third means 3 times 3 times 3. That's 27. How about F? What are you gonna do with F? Flip them. So it's x over 2 squared. Final answer? Wonderful, wonderful. All right, scientific notation. Has everybody in here had chemistry? So you all have seen scientific notation. Scientific notation is when you have a number times 10 to another number, right? That's what scientific notation is. So obviously, this number is not scientific notation.
Oh, yeah.
To put it into scientific notation, we need to move the decimal so that it is right after the very first number. That's where the decimal goes, right after the very first number. Okay? So this is going to be 3.14683. Times 10 to what power? Anybody remember how this works from your chemistry days? The decimal point in the original problem is 1, 2, 3, 4, 5 places I had to move it. So that's a fifth. That exponent is just how many places you moved your decimal to get it where it belongs. So where about this one? Where does the decimal point need to be? Right here, right? It needs to be 7.136. How many places did I move it? 1. Careful, tricky, -1. Did you notice that in this number, I moved my decimal point this way? But in this number, I had to move it this way? Oh my gosh, you mean I have to remember that? No, just remember that if your original number was a big number, like 314,000, your exponent will always be positive. If your original number was a small number, like 0.7, your exponent will always be negative. Negative exponents are for small numbers, positive exponents are for big numbers. it is full. Alright, now we're gonna simplify. Hang on, I'm gonna get to the board here in a second, let you practice. But we're gonna simplify this thing. And I know you're looking at it with great trepidation. But don't worry. You're gonna write it in scientific notation, so you gotta figure out what this number is. Any idea how you gotta do that, Declan? Do you have an idea? It is very easy. If you have a calculator, go ahead and get it out. I want you to multiply 3.16 times 1.43. I'm not doing anything with the tens just yet. We're multiplying 3.16 times 1.43. And then we're gonna divide by 1.23. So we'll multiply these. And then we're gonna divide by, guess, what did you get?
467.
3.67, you rounded that off, that's fine, 3.67?
Yeah.
Now I gotta deal with my tens. So let me just look at those for a second. I've got 10 to the fifth, 10 to the negative 8, and 10 to the negative 10. Hayden, you all right?
Yeah.
Stay focused now. All right. Now, let's fix that. What's gonna happen to these guys right here? They're gonna move. So we're gonna have 10 to the fifth, 10 to the 10, and 10 to the 8. Is that all right, everybody? Good? Now, Bella, it's back to your problem. See how these are both together on the top? So that's gonna total 10 to the 15th. But now this one's on the bottom. They're gonna cancel. Now how many tens am I gonna have left? That's the 7. So times 10 to the 7. So the green numbers, I literally multiplied and divided. The exponents I dealt with just like I did these problems over here. Find out how many tens I was left with. That 10's like an X. You and your partner do E, it's easy. E is an easy problem. You guys do it. Tell me what you end up with. You should have something times 10 to the something. Use your calculator to help you.
I didn't know I needed to.
I don't know about my journal and I still have my
So I didn't know.
like I never used I never borrowed like I
Also never did this before. I just never took chemistry.
What'd you get right here? Okay, 19.096. Is he right? I didn't type it in.
Yeah.
That's right? Okay.
And then
How many tens did you end up with?
we bring it back.
3?
Down.
22.
Whoa.
Is it a division problem? No. So the total goes up and we're gonna get 23. Are we good so far?
Yeah.
I got a hand up over here. I wonder what this is about. Oh, wait a minute. Can that number be 19? Now, no, it is 19 when I type it in on my calculator. But if I am supposed to be writing scientific notation, can that number be a 19? No, it has to be a 1.9096. Because in scientific notation, the The decimal point goes right after the first number. Okay. Now, I changed my number. I went from 19 to 1.9. Obviously, my exponent has to change. Would you agree that it's gonna change by 1? Because that's how many decimal places I moved, right? The question is it gonna be 22 or 24? How many think it's gonna be 22? How many think it's gonna be 24? The rest of you just don't care? Come on now. The 24s have it. It's going to be 24. Now, how did you know that? Mrs. Ford, are you just a genius? No. I knew that because these two numbers have to be the same. I'm just rewriting it. They have to be the same. If I made the first part of the number smaller, I went from 19 to 1.9. In order to keep the overall number the same, if this part got smaller, this part has to get bigger. If you made both parts smaller, then you're gonna get a smaller number. To keep the same number, it would balance it out. If this got smaller, this got bigger, and that would balance it out. So I went from 19 to 1.9. That's getting smaller. That means my exponent had to get bigger. All right, last thing we're going to talk about right now are our properties. So I'd like you to look at number 10. A, B, C, D, E, F, G, H. Are there any of those that you can tell me right now what the property is? You should be able to do it all. But are there any you feel comfortable sharing? Yeah. A is absolutely 100% distributed. Is what? H is 100% distributed. Remember we talked about it earlier. Distributive goes both ways. So factoring is an example of the distributive one. Beautiful. Any others? Really? Is B additive? B is a property of addition. But we don't call it an additive property, but it is a property of addition. What changed in B? What's different? Left side, right side, what's different? What about the order's different, right? The order's different. When the order changes, that's called commutative. I really want you to remember this property, guys. When I say I'm commuting to school, what does that mean? When we commute, what do? We move from here to here, right? We change our place. We're not at home anymore, now we are at school. In this problem, didn't the X and the Y change their place? Didn't they move? When things do that, when they change places, when they move, you're commuting. Since it's an addition problem, we say commutative, and you can abbreviate. Commutative of addition. What about C? What about C?
6 change.
The 6 moved. That is also commutative, Philip, very good. However, on the one side, it was 6 times. And on the other side, it's times 6. So it's commutative multiplication. It was the order of the multiplication that changed. Very good. Ready, let's see any others. Is E what? Is E, it's something of multiplication. I want you to look carefully at E. On the left, the numbers are 6, 4, 3. And on the right, the numbers are 6, 4, 3. Did any numbers actually move? What changed? So what changed was the way we grouped them. When your parents say, I don't want you associating with him, what do they mean? They don't want you being part of that group, right? Grouping is associating. It's how you associate things. So grouping is the associated property. So D, oh no, that was E. E is the associated property of multiplication. We regrouped, move the parentheses, regrouped in a multiplication. What does commutative mean? Commutative means things change places. What does associative mean? They regrouped. They got grouped differently. All right, I'm ready for another one. Yeah, there is a zero property of multiplication, we call it zero product property. G is not a multiple, so we can't use that. What happens when you add 0 to something? It stays identical. It stays the same. This is called the identity. Number 5 is the additive identity. So if we add 0, it's the additive identity. Add 0, you know.
So F would be like.
So F is multiplicative identity. That is exactly right. Because in multiplication, it's times 1. It keeps you the same. In addition, it's plus 0. It keeps you the same. Okie dokie smokies. All right, last one is G. What's happening there? Well, they're canceling each other out, right? Aren't they? I mean, if you multiply 3 times a third, don't they cancel? It's called an inverse property. For addition, it's the opposite. For multiplication, it's the reciprocal. They cancel each other out. This is called the multiplicative inverse. When things stay the same, they're identities. 5 plus 0 is 5. That is the identity. When things cancel out, they are inverses. Turn to last page of your notes. Turn to the last page. It says extra property practice. You and your partner right now, and I don't care, you can work in groups of 2 or 4, move around if you want. I want you to answer as many of these as you can. Give you like 5 minutes, answer as many as you can, last page of your notes, very last page in the packet. them down, and we're gonna talk about them.
It's a good thing like this though.
Yeah, just choose property, write a property, so, like number one, I hope everybody knows number one is, just gonna write
Okay,
this
this is
down.
district.
Move on. Okay? So, see how many of those you, that's all 5 years, you don't have to do it by yourself. On test day, you'll be by yourself.
What is the errors?
Oh, it is.
Yes, it's
Oh,
also.
it is. Yes, the perpetrator. Wait, I have no idea.
Well, that's, I'm just, I feel like that's
Stage right here, it tells you everything.
I got that. I got Von Mars. And they have them. I find it. Wait, it's not.
It's not, I think so. That was just added in. Wait, I don't think
I feel like that one's
added into.
Maybe it's, they have like, or, I guess, I
Oh, why
feel
do you think something like that? No,
They're not bad.
Is it 6 or 8? Inverse.
I also have a basket up here.
Oh, wait, yes.
Oh, wait.
These things, if you are one of those people who
I think
brings
it's
back,
identity.
feel free to take them and check them out.
7 is identity.
Well, it's not in the same order though. I think it's still. Oh, wait.
Oh, it's
This
ordered.
Oh, I actually don't. Because it's like the same order. Yeah. And like this.
That's
Like, but like that could not matter. Because number C is like that. 6.
I think it's associated. Yeah. Yeah.
Yeah. Huh?
Yeah, but
Yeah. I think it's Because it's, yeah, it does like switch the order, but like I don't think that matters. I don't know. It's actually
Okay, guys, let's regroup here and see what you've done so far. Give me one that you got an answer to. Here, I'll write it down up here and see if it's right. What you got?
number 1 is
Yeah, you
Sure, you
have
like
to.
that.
You have to talk about that.
Multi-inverse.
3 is multiplicative inverse, absolutely right. So you should have in have the idea of multiplication and inverse. All right, who else? So far so good. Who else got one? Yeah.
Number 2, I got additive identity.
Additive identity, beautiful. And why is that the identity? Because we added 0. That's the additive identity. Nice. Efren?
What did you do for? I did associative multiplication.
Perfect. It's associative of multiplication. Does anybody not see why that's associative? Did the order change?
Yeah.
ABC, ABC.
No.
So no commutative, no order change. Anything changed, associative. We don't have to go in order, so, I mean, you can go in order, but if you just got another one, I'm ready for that. Yep, 7 is additive identity again. Yep, 6 is multiplicative identity, absolutely. Come on, you gotta get all these done, yeah.
Did we do 10 yet?
Nope,
10. Oh, wait.
go ahead, you're right.
Commutative.
Yep, commutative of addition. Now, number 10 is a trick problem, because I put parentheses in it, right? But notice what changed, not the parentheses. The 3 and the 4 are screwed on both sides, but the order changed. So 10 is commutative, very, very good, yeah.
For 5, I also got commutative.
5, she also, yep, 5 is commutative of addition. You guys, your job is to say why. If you don't understand it, say why, all right? We're trying to get through all these. Okay, what you got?
Is 9 distributive?
9 is distributive, absolutely. It's an example of factoring, and factoring is distributive, perfect. Yep,
Is 8 commutative multiplication?
yes, 8 is commutative because the A and the B moved. They got multiplied in a different order. You guys are bingo on target, right? What else? 11 is associative, but it's addition.
Oh, it's addition.
Yeah. So 11 is definitely associative, but it's addition.
And then is 12 additive?
12 is an additive identity. 12 is additive inverse. Remember, additive identity is adding 0. Perfect. All right, we're half done. Let's go. Yep, 13 is multiplicative identity because we multiply by 1. When you multiply by 1, you're an identity multiplication. Hayden, I need one from you. So 14 to 26, I don't care which one. Tell me something about one of those. Hayden, look at number 18. We practice these, what's happening in number 18? It's distributed. Don't need to phone a friend on that. That's distributed. Yep. And then I need one from you. Give me one. 25 is multiplicative identity, absolutely. Perfect. Whitley,
17 is also multiplicative.
17 is also multiplicative identity. You are right. Anytime that you multiply by 1, you're multiplicative identity. 16 is additive inverse. Yeah,
14 associative multiplication.
let me look is associative of multiplication. Look at it carefully, guys. Order didn't change, only the group didn't change. That one? 24 is multiplicative identity. Let me say it again. Anytime you multiply by 1, you're multiplicative identity. Okay?
Is 15 commutative?
15 is commutative of addition, yep. Perfect. Yeah, 19 is multiplicative inverse. I spell it as atrocious. Alright. Why is it an inverse? Because you are canceling them out. You're getting one. Cancel them out. Yep.
Is 26 the addition inverse?
26 is added to the inverse. Yep, you're exactly right. Again, they're canceling out. Put your hand up, sweetie.
Yeah. That's, and 20 is as associative.
Are you talking about number 20?
Yeah.
Okay, let's look at number 20. That one is really confusing. There's so much going on. She said, change your road? Number 20 is commutative because what happened? The parentheses, not what's in them, but the parentheses change places. So yes, number 20 is
Also
commutative.
22.
Wait just a minute. Commutative addition. What about number 22?
Same thing as 20.
Now, look at number 20. I'm gonna say the letters, X, Y, P, Q. And then the other side is P, Q, X, Y. They changed. In number 22, 7, 8, 9, 7, 8, 9. Did the order change? Associative. Number 22 is associative. Addition. Oh my gosh, what's 21? Distributive. And last one, number 23.
What'd you say?
Commutative multiply?
And it's commutative of multiplication, guys, because one side is 5AB and the other side is A5B. They moved. They moved. That's commutative. Okay. Now. You give me your homework back. Years ago, I simplified homework because I want you to do it. I don't want it to be an overwhelming task. I don't want you to have so many problems, you say, oh, bad, bad, bad. Second of all, I don't want you to cheat on it. I don't care if you help each other, you can do assignments together. But don't photomath it, don't let your tutor do it for you. Do it yourself. Because when I grade it, I'm gonna grade it, and I'm gonna mark things wrong if they're wrong. But if you do the homework, you get 10 out of 10. Unless you miss everything. If you miss everything, then you won't have the answer. But I don't grade, I grade it so you know what you missed. But the rest comes after. Just do the homework. Your homework due on Thursday is just this front page. You're gonna rip it off and turn it in, okay? It is on scrap paper, so it's literally just the front. I don't know what's on the back. It looks like some kind of football thing or something. Doesn't matter, I did this out of the recycle. So you just do the front. On Thursday, you walk into class, put your stuff down, put your homework in place. Okay, that will play right there. If you're one of those people that, oh, I got resource next period, or I'm gonna do this at lunch, feel free to bring it by after school. Feel free to bring it by tomorrow morning. I don't care, as long, it can be early, it just can't be late. I want it by the beginning of class on Thursday. Everybody clear? Okay. just like the notes. You get one homework packet, and if you lose it, then that's on you, you're gonna have to figure it out. Alright? I waste enough paper, I don't need to waste it because you are careless. Just as an FYI. Wednesday, we may have our first quiz, but we will practice. We never have copy, never copy. We always practice ahead of time. So, be ready for that perhaps on Thursday. We don't get it Thursday, it'll be Monday.
That would be murder.
Well, there you go.
Only
That,
bag
my
eggs, my
friends,
sheet,
is the
APDs.
first 85-minute period I have ever taught in 26 years. What is it?
I wear my nice glasses.
Don't get your phones out.
No one.
Yeah, bro, it's not even that deep.
What's your class? AP African.
And then,
You're gonna meet the new.
Yeah.
Friday doesn't matter to me because we don't have
Yeah,
class on
every-
Friday.